Welcome everyone to this Codurance meetups. My name is Christian and I will be today's facilitator for Javier's talk. As you may know, Codurance was born from the community, so that's why we are recording this session to be able to create content for all our channels. And that being said, I'm glad to introduce you, Javier, who recently joined Codurance as software craftsperson. Really happy to have you in our team. And today he will be continuing with the Python meetup series, talking about patterns and how they can be applied in Python applications. Don't lose the opportunity to register for the next one. So there will be 3. This is the second one. And I will be also sharing the link for that. And you can participate during the talk by writing your questions or just waiting till the end where you will have some time to ask directly to Javier. But please don't be shy and ask some questions and say everything you need. So I will shut up now and please give a warm welcome to Javier.
So thank you, Christian. Welcome, everyone. I'm really glad to have you here. And let's start. First of all, this is as Christian mentioned, this is the second session of a series of 3. And this will be focused on patterns, design patterns in Python. Okay, I will make the ID smaller. So I think Christian will share in the chat the repository and these slides, so you can follow the presentation and you can also interact. The repository is in GitLab and you will find here the whole explanation and the code that you need. Okay, so patterns in Python. Okay, first of all, goals for this session. As usually, 3 pillars also. First of all, code happily. I will be really glad if you check the code, clone the repository and code at the same time with me. So the second is provide some value. So first of all, I'm not the referent expert, I'm not the guru. I'm just also a developer as you are probably, and I'm also learning. So the goal here is to rise our knowledge, improve our knowledge together. Okay, so keep this in mind. And the last point is to research. There will be things new during the presentation. There will be things that you know already or you know really in deep. So please be free to speak up, interrupt, make any comment in the chat, because we will be reading you and trying to interact with you. So this is a meetup. It's not a lecture that I'm giving. Okay. And because today is Monday and it's a hard day, no, starting the week. So I just want to remind you that the feeling that we want to achieve here is like Indiana Jones, no? Like we code, we develop software, but we want to achieve this thrilling feeling of discovering new things, going into the unknown. And because the 3 sessions that I plan on Python are based or using Indiana Jones as the conductor topic, just want to remind you, or just want to go with you to this small clip. Okay, so we review the first trial. Okay,
sorry, you are not sharing your screen. Just remember that we
sorry my bad, because I was sharing it before. Now so nobody interrupt me. Thank you, Christian. So I will start from the beginning. So this is the title. This is the goals for the session. So please code happily, provide value and research. And the mood that we want to achieve is the mood that Indiana Jones has in this movie, without so much pressure. Okay. In the first session about testing in Python, we went through the first trial, okay, where Indiana Jones is here trying to rescue his father, and he passed the first trial. After passing that, he has to face the second trial, and it's the trial that we want to face today. No, we went into the unknown, and we see our messy code full of letters, full of things that we don't understand. So we have to walk along the tiles that are not a trap. Okay, so we should approach to the tiles will be the patterns in this case that are not a trap. So the proper tiles, the proper patterns. Okay. As you see, Indiana Jones realized about that and jump from pattern to pattern into a perfect sequence until, well, with some thrilling moments, just to reach the other side of the trial, okay, of the test. So with this, we will review a little bit the plan for this session, okay? So first of all, we will review some definitions because the audience could be really broad, and I don't know, I want to establish some basic definitions for you. We will check a little bit the tools that we have available in Python, or, well, mainly a small comment about one tool, and then we will go through 4 different examples of different patterns, 4 different patterns. These patterns will be the abstract factory, the builder, the decorator, and the observer. Because I am taking as a reference the design pattern of the book of Gamma, the famous Gang of 4 book. I use the name that they use. So these 4 patterns are in the book, okay? Finally, we will summarize a bit the session, okay? So why patterns? So because patterns are everywhere, no? This is just something that we cannot escape. The humans are really good at discovering patterns, and software developers made the same. And by facing problems while developing code and providing solutions, they discovered that some problems could be easily solved in certain manners. And these manners is what they call design patterns, okay? So basically, a design pattern describes a problem that often pop up in development and then describes a solution for that problem, okay? In the book of the Gang of 4, they were classified in 3 big groups, the creational patterns, the structural, and the behavioral, okay? So some remarkable points of the book are that when programming, we should always program into an interface, not to an implementation, okay? The book is based on using object-oriented programming, and this will be the paradigm that we will follow during this session. So it's good to favor composition over inheritance, and always design with the change in mind. So it's likely, and we can see it in our daily lives, that the code changes because the business has some needs, the system has to evolve to adopt new technologies or other reasons, okay? So to master this topic, this really complex and wide topic of design patterns, we should focus on control the granularity, okay, the size of our objects, the coupling, and the cohesion between these objects, okay? And this will be all what I said now about design patterns. I will make a brief comment on Python. Probably many of you are Pythonistas or Python developers or programmers. Well, in the community, it's widespread the duck typing, but there is a package called ABC for constructing or implementing some interfaces. Okay, so in Python, as you can check in the second reference in the Fluent Python in the book, in this book. Okay, this Fluent Python. In the community, it's more usual to talk about protocols, but in other communities, we talk mainly about interfaces, which we can apply it also to Python, but with almost the same meaning. Okay, so this is the only clarification that I want to make about Python. And now let's start. No? Let's go to the code and let's see. So first thing is the abstract factory. When I was planning the session, I was not sure whether I should use a class diagram. So finally I did it. So just to give you the broad idea, okay? So what we will have in this pattern implementing is a client here on the right that, I don't know if you can see my cursor of the mouse. I think you can. Okay, so that is using an abstract factory. This class of here, this widget factory, is an abstraction, okay? It's an interface. So then these two other factories are implementing this abstract factory, and these factories produce different classes, okay? So summarizing it, a factory is a class that will produce, or an entity that produce other classes for your application, okay? And the idea here in this pattern is to have an abstract factory so that you can have different specific concrete factories. So in your contract with the application, within the client, you adhere to that interface, to that abstract factory, and then you can interchange these two factories, okay? But we will see, wait a moment, we will go to the code and perhaps you will understand it better. Okay, before anything else, the repository is really simple. There is a folder called patterns Python, and within there are subfolders that implement the different patterns. Within the pip file, you can see the different scripts to run the code, okay? So let's start with the abstract factory. In this situation, imagine the next. We have one application, okay, that is doing something like this. Pip-m run abstract factory, not solution, but problem. Okay. In this application, this application is about sending notifications. Okay. Imagine that you have a client ID, which could be Javier, which is my name, and then the application gives you the opportunity to get an offer, to enqueue an offer, or dispatch the offers of the day. Okay. And the notifications, if you get an offer, will trigger an urgent notification. And if
Sorry, Javier, could you increase the font size a bit?
Let me check. Let me check. Settings, editor. Okay, now it's better, or still too small? It's okay?
Yeah, it was Jesus asking for that. Yeah. Okay, thank you. Yeah, we can continue.
17. Okay, let's try with 17. Okay, so what I was saying is that in this case, the application, when the client get an offer, should trigger a urgent notification. When the client queue an offer, it will store a notification, and when the client dispatch an offer, it will show all the notifications. I will show you this. So if I press 1, you see that there is a warning coming from the logger or the notificator my app. There is an urgent notification. Okay, if I press 2, nothing is shown in the shell. If I press 2 and 2 like 3 times, and then I press 3, you see that we can see all the store notifications. Okay, and I can exit my application with that. Okay, this is a bit abstract example, but imagine a system in which you have an application and you want to get a notification in Slack, which is relatively common. Okay, so reviewing the code of the problem, we see that this is my app. This is the menu that you have seen in the shell, and we have a class client. Okay, that is implementing in one of the properties the urgent notification and the daily notification. Okay, so in different files here, we have the urgent notification, which is just importing a logger from this loggers file. Okay, it's importing the application logger and just showing on launching a warning. Okay, and the daily notification is a bit more complex, but when we call notify, we just store it in this dictionary. And when we call dispatch with the option number 3, what we are doing is triggering a log info. Okay, as we have seen here, we have info. Okay, so what if we need to have 2 different kinds of notifications? And this is also pretty common. So we need to have an internal notification for the workers in the company and an external notification system. Okay, you can think even more complex situation like having a notification system per country and so on and so forth. And imagine that the internal notification is sending to Slack and the external notification is sending an email. Because I want to keep this simple, everything will be notified on the command line. Okay, but the thing is that looking at the code that we have here, that will be relatively hard. What will you do? Will you duplicate the urgent notification and you will have one notification, internal, external, there will be no contract. Indeed, this is there is no contract here. By contract, I see a common interface. Okay, like this contract here, the client ID should be a string. This is kind of a contract. This will be really really good using it together with MyPy and to keep track of the types within your application. Okay, so we kind of agree, or you have to believe me, that changing this in a bad manner could bring a lot of problems in the future. Okay, so we should look for a scalable, maintainable solution, and for that is the pattern of the abstract factory. Okay, so if we go to the code right now, we start from the main. So in the main we have something similar. I will do something I will close everything here. Sorry. I will go to the problem and open the main, and I will open the solution, and we will put it side by side. So this is the problem, okay? And this is the solution. And let's see how it is. So the menu that we have in this small application is the same, okay? But now, instead of having the client here, what the first thing we do is to call or to define internal or external notification factories, okay? And we pass these factories to the client, or depending on the client ID, okay? So if the client ID is in the repository, and the repository in this case is super simple, it's just a list with my name. So the only user in that company will be Javier. So if you introduce Javier, you will have notifications, internal notifications, okay? If not, you will get external notifications. And we pass this notification to the client. The first thing you notice is what I said before. Notifications is defined here. And now we have a contract, and this is good. And even more, if we go to notification factory, which is in this factory file, is the famous abstract factory from which the pattern takes the name, okay? So what we are doing is, okay, we need for this application to generate urgent and daily notifications. But on top of that, there will be two really different environments, a way of sending notification. So the internal and the external. So let's create an abstraction on a factory that then when we implement it, can send internal or external objects, okay? And this is what has been done here. So what we do for defining the interface is using ABC. If you don't know, go to the reference that I left in the presentation, or check it in the documentation of Python. And we create the contract of two abstract methods. Why two? Because we need to create urgent and daily notifications. If, for instance, we will need to create many different notifications, we will have all these contracts, all these protocols or methods defined here in this abstraction, okay? And then later on, we implement the internal notification and the external notification factory, the two factories, concrete factories. So going to the diagram, this widget factory will be our notification factory, and these two specific or concrete factories will be, in our case, internal and external notification factory, okay? So will be specific. What else it changed? When instead of having a concrete or specific class, if we go to the urgent notification, now we also, or we can see that we have also an abstraction, okay? And this is better than before, because instead of having a specific object that we have to use inheritance or subclass from it, we are using an abstraction, and we can implement a subclassing from that abstraction, okay? So we have a contract, and we fulfill the contract in different ways depending on internal or external notification. And the same happened with the daily notification. We abstract it in a class, and then we implement the internal and the external, okay, within the daily notification file. So the only difference, by the way, the only difference between the two the internal daily notification and the external is that the internal is using the internal logger, the external is using the external logger. This could be maybe improved by not using or not repeating myself, but I left it like it is for clarification or for clarity. So internal and external loggers are defined in the loggers file and are just two different loggers, okay? As we define loggers in Python, one called internal and external. So the goal that we wanted to achieve is to have two different systems, no? So if we execute now the solution, okay, we go for the only client that is internal, in this case, my name, Javier, and we execute as before the urgent, poop. We have the same warning as before, but this time executed by the internal logger, which is what we want. Imagine in this case will be a Slack message, okay? Because I am an internal user. And the same as before, if we press 2 times 2 and then dispatch the offers, we will get 2 notifications in this mock Slack, okay? And we can exit. But the improvement comes here. If we execute it again and the client that is Barcelona or whatever, Barcelona is not an internal user, so for us will be an external user. So if we send an offer or we get an offer, instead of getting the internal or using the internal notification, we have the same warning, but now we have an external, we are using an external notification system. In this case, it's here, but could be an email to the client ID. And the same if we press 3 times 2 or 4 or 5, and then dispatch all of them, we will have the notifications, the same info, but using the external logger, okay? So the benefit of this pattern is basically that we have a contract and we can have different implementations of that contract. And in this case, the contract is with an abstract factory that when implemented, that abstract factory can really have a wide, a rich offspring of objects, okay? So we can implement it in different ways. So far, so good. You understood more or less, Christian, the example and the benefits of using this?
Yes.
Okay.
All clear for me. Is there any question?
If any question, please interrupt me or, I don't know, tell me you are going too fast or too slow, or I don't believe you are in inheritance. I don't know, whatever thing you want to say. So far, so good. If not, let me continue, okay? This is the first pattern. So the second is the builder, okay? We expand a little bit the diagram. Okay, the builder basically consists in that we will have a class instead of instantiating the object or the class that we need directly by ourselves. Imagine that we need to tune that instance or the instances of that class in a flexible manner or with many different parameters, okay? So our application, in this case, this parse RTF, instead of instantiating a specific class, we will instantiate a different class called the builder, and that builder will perform different operations or will contain, that builder will contain an instance of the class that finally we want to use, okay? And using the methods of that builder, in this case, for instance, convert character, convert font change, convert paragraph, using this method, we will add properties to the class that the builder keeps inside, okay? So the builder is, okay, I generate one instance for you and give me all the features by calling my method that you want to have. And at the end, you will call a method that for as agreement we will call build, and I will return you the instance that you are looking for with all the properties that you were looking for. Okay, more or less in 1 second in the IDE, okay, with the code. As we like it. We like it, the code. So in this case, we go to the builder folder, and as before, we have the problem and the solution. Okay, I will close this. I will open the main problem. So in the main, in this case, our application will not be a notification, but will be something that I like it. It's like a character, a role-playing character generator, okay? So if you enjoy role games, you are always in the need of, what a surprise, eh? Normal people know, but people like me always feel the need of creating cool characters and play because we find really fun that. So sorry for this. Let's focus. My app in this case is just have a small menu, and then it's instantiating the warrior class and then printing on the screen. So if you need to have some stats about a warrior, you will have it here, okay? So when we check the warrior class, we can see in the constructor, in the init, dunder init, that we are using a random generator of integers between the range that usually a warrior has to generate this. We are also randomly choosing the weapons and choosing the armor. And then we just implement the dunder representation just to have a nice print. If we prepare run builder solution problem, what we want to do, a warrior, of course, and what we will have all the properties, all the strength, dexterity, constitution of the character, the weapon and the armor. I'm sorry because I don't know why. I think there is a bug in PyCharm IntelliJ that is not rendering the emojis properly in the terminal. If you run it in Visual Code, you will have a much better experience. But at least you can have it in the editor itself. Okay, so but then imagine what if we want to construct to build up not only a warrior but a warrior that comes from a dwarf warrior that comes from the mountain, and maybe also a ranger. So the builder pattern comes into rescue. So we can see the solution as before. I will do the next, which is moving this to right. So we have the whole implementation in one single file, and now we have the solution which has the main, the character, and the character builder. Okay, so in this case, my app has a more complex menu. Why? Because we want a ranger, and we want that ranger could be an elf or a dwarf or a human. Okay, and let's go in deep later on. So what we are doing here is to store in the character, depending on the choices, a warrior builder or a ranger builder. Okay, so what is that? What is that? So if we go to the character builder, we can see, as same as before, a construct, which is an abstract, an interface, an abstract class that we can use as an interface to later on implement the concrete classes. Okay, so the character builder, what it's doing is having a class parameter, which is the character. Okay, there will be an abstract method, which will be the base, and there will be a build method that will return the character that we have stored in our class. And this is the key part, basically, these two things that we store in the class, in our implementation, the character class. So we have before the warriors, and now we have the character. Okay, and this build method that will allow us to return that class, that character class that we have created before. If you go to the character class, here is like really similar as before, but we can scale it up much better because now the constructor just put really empty values on that, and well, it set the default race to human, and the representation is the same. Okay, nothing fancy here. But now this builder interface that we have here, we subclass into the warrior builder and the ranger builder. And what we are able to do in this is that we implement, for instance, the abstract method base depending on our profession. Okay, because if you are a warrior, you will have these random skills, but if you are a ranger, you will have different random skills, okay, and different weapons and armor. Okay, but we can also use or implement in the abstraction a specific method that could be common for both subclasses. Okay, so when we go to the main application, you can see that the character store the warrior builder or the ranger builder. Okay, so in character, well, maybe we can call it a character builder here. If you said, okay, it's much better name, I can agree with that. So we can do it like that. And then when we implement this character builder and we call the base from the mountains and then build, we can create one kind of character. Okay, and I will show you how it's work. Solution. Okay, so in this case we have the warrior and the ranger, and we have 2 and a 2. Okay, and you will say, okay, you select an elf but you have a human here. Okay, why? Because I want to show you the benefits of this solution. And the benefit is that if you notice, we are not using the race here, but just by doing this, so basically, of course, changing also the variable. So just by adding this piece of code here, we can now run it and have the benefit of we press 2, and now we have an elf ranger. Okay, so just by adding that, which is really scalable, you can have a different kind of character. Okay, imagine a more complex object or class that has to implement a difficult interface, for instance, a communication class that has to deal with AWS services, and you have to set the region, you have to set some delays. So this will be really useful because adding or calling different methods that you can understand pretty well. So if I call race, you can infer that I am setting the race for that character. Or if this will be a DynamoDB consumer and I put .region, you will understand that I am setting the region for that consumer. This improves the quality of the code and the scalability, okay? And that's the reason that I understand all the benefits behind this pattern, okay? So far so good. I will increase the pace, hopefully, or a little bit, not hopefully, because I am talking too much. So the next pattern is the decorator, okay? Okay, the decorator, what it's doing is, imagine we have this abstract class, okay? And we have a concrete implementation, in this case, text view, okay? So this concrete class, we want to, or we are not sure, okay? We know that in the future, we will need to add some functionalities, but we don't know which ones, okay? So we want to make it flexible enough to grow, okay? So the trick here is that, okay, we will create a new class that we will call it decorator, okay? And this class, we will have an implementation. Oh, well, this class, the decorator, will subclass from the same class as text view, okay? This abstract class visual component. Decorator is subclassing from there. And on top of that, it will have as a component one element from this abstract class visual component. For instance, this decorator class could have a text view, okay? So maybe you don't see the benefit, but you will see in a second, okay? Let's go to the examples. Let me close this, close the builder, and go for the decorator, okay? We have the same problem and solution, okay? So in this case, the example is a bit different, okay? What we have here is a really dummy cell application, okay? So let me prepare run decorator solution, no problem, okay. And what we have is this cell, okay? So I can say, hello, thanks for coming, correct me if I'm wrong. And the only thing is that if I call history, here I will have all the history that I put before. And if I type exit, I will exit. So simple. So it's just that, okay? So we have an application here. So that application is instantiating the shell class, and this shell class requires a basic prompt. And the prompt is these two arrows, okay? I'm not sure if you call it this prompt. I think it's the proper name, but forgive me if it's not the proper name for these two arrows, usually in a terminal or in the console, okay? But and the problem here is, okay, now we want, so look at my prompt here in my console. I have the time, I have the Git branch, I have also the host, the name of my computer, my name, Javier. So this is really nice. And we will have to have also the date and the host name and some colorful, okay, how to make it in a way that we can scale, okay, and that we can reuse. And the solution for this is the pattern decorator. And let's go to the main. As before, we split the main. So we have the old version here, and now we have this new version. Okay. So in this case, my app is doing or calling, instantiating one basic prompt, which is different. It's a basic prompt, sorry, it's not different, it's the same as the basic prompt as before. And then calling some decorators that we don't know yet what it is, and passing this basic prompt to my prompt, and each one of these decorator is receiving this basic prompt as a parameter, okay, in the constructor. So at the end, we will have my prompt here that is going through this all this if. Why? Because we have the proper parameters here. Give me a second and we will see it in action. So the cell prompt in this case is not expecting a basic prompt, but is expecting a base prompt. And this is, sorry, because the names are pretty similar, but they are different. So what is a base prompt? If we go to the prompt.py, we can see that base prompt is an abstraction, okay? And the basic prompt that we have before is a subclass of that abstraction. As I mentioned before, in this case, basic prompt in the presentation will be this text view. And the base prompt will be the abstract, the interface visual component, okay, for establishing similarities and that you don't lose the track. So the trick here, the strategy is to, okay, we will create a new interface called prompt decorator, which is the interface decorator. And what we will set is that this decorator in the constructor will receive by contract something that belongs to the base prompt, something like, for instance, base prompt. Okay, but we can receive also prompt decorators because prompt decorators are subclassing from base prompt. Okay, so we can receive the basic prompt and whatever implementation of prompt decorator. Okay, and what we do now is that in each concrete decorator we do the next. So we know that we have in one of our properties one element of the base prompt class, okay? And this base prompt class has a print. So basically this arrow that you saw in the console comes from a print, from this print, okay? So the decorators, what are doing is, okay, because I know I have in my properties and a class of the base prompt, I know that I can call print. And then what I can do is to add some modifiers or change the element that I got from this class that I have in the properties, and return a different value. So in this case, we have a daytime decorator, a host decorator, and a color decorator. The daytime will put the time. The host will put the host name of my machine, and the color will add some color to the string in Python. Okay. So if we go to the main before, and you follow, now that you know this, we have a basic prompt similar to the one that we have in the problem. And now we store this basic prompt in my prompt. And then, depending on the ifs, we are passing this my prompt to the different constructor of the decorators. And what we receive from the instantiation of the decorators, we are storing it back in the same variable. So at the end, we are chaining the decorators, okay? to get the effect or the result. So now if I launch the shell with the solution, what you see is that now I have Cáceres, which is the name of my machine, and the datetime, and we have also some color, okay? So in a really easy manner, we add new features to our application in really a scalable way. It's kind of similar to the builder, but it's not during the construction of the or creation of the class, okay? So is when we have a class, we can append some functionalities, but using this pattern. One thing that we should be aware and we should remember is that the order in which you change the decorators will matter, okay? Because if, for instance, instead of calling the color decorator here, I move it here, what do you think that will happen? You are muted, Christian.
It will switch the position of the, well, the color it won't affect, but if you move the time, it will, right?
Exactly. You got it. So what will happen, let me exit this. What will happen right now is that the color decorator is affecting only to the basic prompt, but not to the time and not to the host. So we expect to have color only in the arrow. So as you can see, is what it is. We can put the time before, and we will have only the time and the arrow with color. Okay, so this is a really neat way of applying a pattern and get really quick benefits from it. I hope you can see the advantage, because otherwise people can start implementing here a new method. Really making it really convoluted code, which will not benefit your team or your company. Okay. So last one, and let's see if I am brief or not. So far, so good. Any question? I'm not following the chat, which is another window. So I will close here.
No questions.
So, no questions? Okay. So in this case, the problem is like the next. Imagine you invest in cryptocurrencies, which is really trendy right now, and you want to have always a comparison between Bitcoin and other cryptocurrencies, okay? Because you are kind of a data scientist, you know that you can use matplotlib to plot this graph on the screen, okay? Oh, wait. Let me go back because I will explain before the pattern. So first of all, the pattern. In this case, what we are going to do, or what we want to achieve, is to have two main classes, okay? One called subject or observable, okay? And one class called observer. And the trick or the goal here is that every time we notice a change in the subject, the observer of that change can take some actions, okay? For that, we will need two methods here for attach and detach observers, and one method to notify to all the observers that there has been an update. And that update is up to us, depends on what we consider that is worth a notification, okay? So, yeah, sorry for that. So the example this time is what I told you. We want to keep track of cryptocurrencies and we want to plot the differences between Bitcoin and two different cryptocurrencies, Ethereum and Tether, and we have this huge, really ugly application, which what it's doing, people run observer problem. What it's doing is this, it's kind of, okay, plotting, but what if the Bitcoin is changing? I mean, this is nothing, this is not static, this is changing the whole time. So what we want is a method that keep track, observe the changes of the Bitcoin and the other cryptocurrencies and plot them into the figures, okay? Okay, so in this case, not new, open. In this case, the main, my application is much nicer, okay? What we are doing in my application is to define two observers, which in our case will be the figures, because we want to render every time we have a new value of Bitcoin, okay? So the observers in this application are the figures that we are plotting. We define also these three cryptocurrencies, which are what we want to observe, okay? And we define, we put it in a endless loop, and we keep track of the changes, okay? So the idea here is that instead of before that we have this crypto price, okay? In this case, we will have this class here, crypto price, okay? And this, in this case, doesn't need to be an abstraction, an interface, or subclassing from ABC. We can implement it as it is, basically by telling in the constructor that we will have a collection, in this case a dictionary of observers. The symbol will be the name of the cryptocurrency, and the values is a list with the different values that we are sampling from whatever provider of cryptocurrencies, okay? As I showed you before in the diagram, we need to implement one attach method and one detach method. What for? For adding observers to our collection, in this case to the dictionary, and to having a method to detaching, to stop observing this cryptocurrency, okay? And we need also a notify method that what it's doing is, in case the observer is not empty, it will go through the different values and will send the name of the cryptocurrency and the current values that it has stored, okay? So far, so good. So we have here a specific or subclass in the cryptocurrency just to implement the sample. And in reality, I'm subclassing because you can get this value from one provider or other provider, from a REST API, from a database, from a Kafka, depends, okay? So in this case, we are faking it totally. So we are generating a random value, and important, we call the notify, because by the logic of the application, we know that every time we sample, all the observers should be notified, okay? And the observers themselves, well, the observer is just, in this case, an abstraction that has an update method, because the real observers are the different figures, okay? they subclass from the abstraction, from the interface, and they are mainly a probably figure. Okay, so when they receive an update, they will clean the current plot and replot with the values. Okay, in the book you can see that the example is 1-to-1. In this case, one observer is observing two observables, two subjects. In this case, we said that one figure needs to keep track of the Bitcoin and different cryptocurrencies. Okay, so the key part is this part of the crypto price in which we notify the different observers, and this key part in which we have a collection of observers. Okay, so is the observable who keeps track of who is watching and telling them, okay, I changed my state, you get a notification. Okay, if we translate this or we check the main again, this is what we are doing here. At the beginning, we create 3 cryptocurrencies, okay, that will be sampled, and we create 2 observers, in this case 2 figures. Okay, so we call the attached property of the Bitcoin to the figure 1, and we call the attached property of the Bitcoin to the figure 2. So both figures are observing the Bitcoin, and independently, figure 1 is observing Ethereum, and figure 2 is observing Tether. Okay, so in this endless loop, I just sampling every second. Okay, and I just want you to keep an eye on this. This is not needed, but I put it for the sake of showing you that after sampling 10 samples, we will stop, or figure 2 will stop looking at Tether, and figure 2 will stop looking at Bitcoin values. Okay, I will show you. I put this here to show you in the demo that you will not see the plot or the figure updating. And after 20 samples, we will reattach the Bitcoin price. Okay, so after 10, the figure number 2 will not continue plotting, and then after 20, it will continue plotting just the Bitcoin values. Okay, so if we solution. So I hope you can see that we have figure 1 here and figure 2. Okay, and they are changing their values every second because we are sampling, or we are receiving from a REST API. But notice here we stop sampling while this figure 1 is keeping track of the different cryptocurrencies. This stop. Why? Because these lines here. Okay, so now after 20 samples, we keep track of the Bitcoin again. Why? Because we reattach this entity, this object, this class to the observable, in this case to the Bitcoin, to the cryptocurrency. And I will close it just to show you that this is not hard-coded. I will execute it again and likely have new random values, same behavior, okay, as before, but the values are random. This is much better because again, we target, or our goal using patterns is modularity. So we have different classes with cohesion between them, but flexible enough to modify the behavior of our software without bringing a really extra cost. Okay. Yeah, this is the end. Thank you so much for listening and pay attention to the examples. So my summary. So this is a nice beginning. Maybe you are already experts, but there are a lot of patterns out there. In the original book, there are 23 patterns. Okay. So my advice is that go for them, implement them. So it's really nice exercise to take the book, to mainly the book, because it's a good reference. Instead of reading a blog, go to the book and try to figure out an example that is valid for you. So use them and talk about them. Why? Because one of the benefits of patterns is that establish a common language between developers. Okay, and this save a lot of your time, because if one developer see a problem, you can tell your colleague, okay, maybe we can implement here an observer, and the other person will have already in mind the idea of the observer, or a rough idea, which is good. So if you don't know about patterns, it will be more difficult for you as a software developer to interact with other colleagues. Another benefit of working on patterns is that you will avoid the the, the the pillow in which the usual frameworks put us on. So we are really used to work with frameworks, and the frameworks below the surface implements many of these patterns and relieve you or put the pain away from you. But I don't think that this is completely good, because you will learn a lot, you will improve as a developer, and I think it's a really nice goal to target for being a developer of a framework, and then you need to use and manage all these concepts. So this is the end, people. I hope you enjoy. I left here some references. The code is in the repository, and now it has been 1 hour already. So I'm open to questions, to listen to you, to complain, to say whatever thing you want to ask. Do it now. Also, if you are watching this later, just reach me by email or reach me in GitLab or whatever, because I will be really open to interact with you and listen to you. And, yeah.
Thank you, Javier. Virtual applause. Thank you. Thank you very much. It was really interesting. I have just one question that it comes sometimes to my mind. It's because we are really used to work with this kind of patterns, or to see them quite usually. But how will you suggest to newcomers or to people starting with this to analyze and to see how to apply them? Which will be your advice on that?
It's a good question. We are all, I think we are always newcomers to this profession. I mean, there is always room for learning. And so my approach is to take a problem and try to look whether I can implement one of these patterns. Okay, this will be one strategy. So a different way of facing it is I will go to a place where I know they implement a specific pattern, and then I will study why they did it this way, because we learn a lot by reading the code of other people. So there are many frameworks open in GitHub. You can take a look. And the third approach will be, okay, well, not third approach, but also a recommendation is listen to people of other communities, okay? If you are in Python community, you are focused only in Python, try to move to a different community. Try to develop something in JavaScript or in Java or in PHP or in C++, okay? Especially the communities that are widespread use in the industries, or that sounds more professional, like Java, have better bibliography and better examples indeed. One of the links in the presentation, the second link in the reference, is about the Java place, where you can have really, really nice list and implementations of all the 23 patterns and more. And so always keep track on other communities, because maybe your original community is Python, but you will grow a lot from listening to other communities. And these three advices will be.
Good one. Thank you. And if no one has any questions, we can wrap up here.
There will be a third part of this
Indiana Jones
trilogy, exactly. Remember that there is a first part focused on testing in Python. There is a repo also and a presentation. There is also a blog article and some podcasts related to testing in Python. And the next one will be focused on architecture. So clean architecture, when we have a good knowledge on patterns, on classes, relationship of classes, or even without classes, if you follow more functional approach. Okay, now how we put everything together so that we can scale a real project in a proper way. So, and don't follow the traps of, oh, this is really simple, I don't need a structure. So this kind of stuff will be treated in September in the third part of this trilogy. Yeah.
It will be interesting, and you will find us here. So what else?
Exactly.
Okay, thank you, people. I think we can wrap it here. Please, if you have any questions, reach us on Twitter, on YouTube, any link I shared. Also by email, anything you need, we are here. Thank you all for coming, and thank you, Javier, for your time. It was really interesting. So
thank you, everyone. Thank you, all of you, for watching this. We learn together.
Yeah.
See you.
Okay. Bye, everyone.